Ever noticed how empty query parameters can clutter your API requests or even cause unexpected behavior? You'll see how FastMCP 2 automatically filters out none values and empty strings from query parameters, ensuring clean, predictable HTTP requests every time. This example demonstrates exactly which parameters make it into the final URL and which get silently dropped.
Hash when calling this tool. Await client, call tool, search products. Category, electronics, hash included. Min price, 100 hash included. Max price, none hash excluded. Brand, hash excluded. Hash the HTTP request will be get/products, category equals electronics, and min price equals 100.
This demonstrates intelligent parameter filtering for API requests, a pattern that automatically cleans and validates input data before it reaches your backend. The concept revolves around treating empty or null values as intentional exclusions rather than explicit zeros or empty strings, which prevents unintended side effects in query parameters. What makes this distinctive is its implicit handling of data hygiene without requiring manual validation logic in every endpoint. The pattern works by applying declarative rules during request serialization, where the framework inspects each parameter and excludes those with falsy values like none or empty strings. This creates a separation between the raw input and the actual HTTP request, ensuring only meaningful data is transmitted. The approach is particularly effective for query-heavy APIs where optional parameters are common, as it prevents malformed requests without explicit null checks in your code. This matters because it eliminates an entire class of validation boilerplate while making APIs more robust. Developers no longer need to write repetitive parameter cleaning logic, and clients avoid unexpected behavior from null values. The trade-off is implicit behavior that requires documentation, but for most APIs, the reduction in code complexity and improved reliability outweighs the need for explicit parameter handling. It's especially valuable when integrating with AI clients or third-party systems, where input consistency can't be guaranteed. Let's break it down line by line.
Hash when calling this tool. Await client, call tool, search products.
This invokes the search products tool via the FastMCP client. The await handles the asynchronous call, ensuring non-blocking execution while waiting for the tool's response. This is the standard pattern for calling AI-exposed tools in FastMCP.
Category, electronics, hash included.
This specifies the product category as electronics, which will be included in the API request. The key value pair becomes a query parameter in the final HTTP GET request, filtering results to only electronics products.
Min price, 100 hash included.
This sets a minimum price filter of 100, ensuring only products priced at or above this threshold are included in the search results. The API translates this to a query parameter, enabling server-side filtering before results are returned.
Max price, none hash excluded.
Setting max price to none explicitly excludes it from the query parameters. The FastMCP client automatically filters out none values when constructing the HTTP request, ensuring only valid parameters are sent to the API. This prevents malformed queries and maintains clean URL structures.
Brand, hash excluded.
Empty strings are explicitly excluded from query parameters. This prevents accidental inclusion of malformed keys, ensuring only meaningful filters reach the API endpoint. The pattern maintains clean URLs by omitting parameters with falsy values like empty strings or none. Closes the dictionary argument passed to call tool. This final brace completes the parameter object, signaling the end of the tool's input parameters before the function call executes.
Hash the HTTP request will be get/products, category equals electronics, and min price equals 100.
This demonstrates FastMCP's automatic query parameter filtering. The tool excludes none values and empty strings from the HTTP request, generating a clean query string with only valid parameters. This prevents sending unnecessary or invalid data to the API endpoint. FastMCP parameter handling. The parameter filtering system automatically excludes none and empty string values from HTTP requests, creating clean URLs while preserving required path parameters. Parameters with default values become optional in the generated OpenAPI schema, but required parameters without defaults will raise clear validation errors if omitted. This behavior ensures your LLM interfaces remain robust while adapting to partial input.
The parameter that vanishes from the URL still shapes the request.